Just when you think space couldn't get any more weirder? Hey, check my grammar. The universe throws a curveball in the form of a giant glowing bubble that's too perfect to be real. Astronomers have spotted something strange drifting through our galaxy. And it's not a rogue planet, which is a space body the size of a planet that doesn't orbit any star. It's not a star itself either. It's not even your average supernova remnant. It's a perfectly round sphere, and scientists are stunned. Astronomers were going through data from a super powerful radio telescope when they spotted something that looked like a perfect round bubble. At first, they thought it was the leftovers from a massive star explosion called a supernova. But the weird part was that the object was too perfect. Normally, such explosions leave behind messy, uneven clouds. And the newly discovered one looked like someone had drawn it with a compass. The scientists named the space bubble teleos, which means perfect in ancient Greek. They've already looked at all the possible explanations, but none of them really make sense yet. This strange space body was discovered thanks to a telescope in Australia called ASCAP. It's been scanning the sky and finding all kinds of weird circular objects. This research was part of a project called the Evolutionary Map of the Universe. Some of the faraway circles, known as ORCs, which is short for odd radio circles, have already puzzled scientists. But this one is different because it's inside our own galaxy. At the same time, even though Teleos is technically closer to us, scientists can't quite figure out how close it is. And that's making it harder to understand where it came from or how it formed. The researchers have taken an even closer look at this strange space bubble and found something super odd. It only gives off a very faint glow and only in radio waves, not in visible light or X-rays. Based on that glow, they figured it's most likely the leftover shell of a massive star explosion called a Type Ia supernova, one of the brightest and most powerful kinds of explosions in the universe. This kind of explosion happens like this. A super-dense dead star, called a white dwarf, starts stealing material from a nearby star. It keeps sucking in stuff until it just can't handle the weight anymore, then it blows up in a huge burst of energy. Now that part makes sense. But figuring out how far away is this thing? Strangely, it's not so easy. Scientists have run the numbers and ended up with two possible distances for Teleos. Either it's around 7,175 light-years away, or it's much farther, about 25,114 light-years away, give or take. Depending on which distance is right, the size of the bubble could be vastly different. If it's closer, then it's about 46 light-years wide. That would make it a pretty young supernova remnant, maybe less than 1,000 years old. But if it's farther away, then it's a giant 157 light-years across, which could be more than 10,000 years old. So, which one is it? That's where things get tricky. Scientists have models that tell us how these supernova leftovers should behave. And one of the most important things they expect to see is X-rays. But you might remember that Teleos doesn't show any. Not a single X-ray in sight. That's the big mystery. How can something that should be glowing with X-rays be totally silent? It just doesn't add up and leaves the scientists very puzzled. Another idea the scientists are considering is that Teleos might not be a regular supernova remnant at all. Instead, it might be the leftovers from a rarer kind of explosion called a Type Lax supernova. And this one? It's extra weird. In a normal Type La supernova, the white dwarf star blows itself to bits. But in a Type Lax supernova, it doesn't get totally destroyed. It kind of survives, turning into a zombie star. Ooh. It's damaged, but it's still around. This would actually explain a lot about how Teleos looks and glows. But in this case, it would have to be much closer to us, only about 3,262 light-years away. That would also make it a lot smaller, about 11 light-years wide. The coolest thing here is that there's actually a star at that distance that could be the zombie star that caused all this. But, and it's a big but, like I have, when scientists use other ways to try and measure how far away Teleos is, none of them agree that it could be this close. So, sadly, this theory hits a bit of a wall. Then there's another strange thing: Teleos' nearly perfect spherical shape. That's not normal. Usually supernova explosions are kind of messy and uneven. The blast might push into clouds of space dust or gas, or parts of the explosion might move faster than others. Eventually, the shell that forms gets all lumpy or starts to break apart. But in this case, the object is almost perfectly round, like a balloon, and that's super rare. The only way something could stay this neat and round is if it exploded in a very empty part of space and expanded smoothly in all directions. That's actually not impossible, just really, really rare. Now, considering its unique, probably unnatural shape, could Teleos be an artificial object? Could it be a Dyson sphere? That's a hypothetical megastructure that could completely surround a star and harvest all of its energy. At first, this idea was supposed to explain how we might detect intelligent extraterrestrial life by spotting the energy they use rather than waiting for them to send us a message. You see, here on Earth, we only receive a tiny bit of the Sun's energy. Meanwhile, a whopping 386 billion megawatts are shooting out into space in all directions. Not to waste such a giant amount of energy, a civilization could build a Dyson sphere, or more realistically, a Dyson swarm, loads of solar panels orbiting the star. It would help them capture every bit of that power to run their planet, technology, AI systems, and maybe even space travel across galaxies. To understand just how advanced a Dyson sphere-building species would have to be, scientists use the Kardashev scale. It ranks civilizations by how much energy they can use. Type 1 can use all the energy available on their home planet. Spoiler, we're not even there yet. Type 2 can harness all the energy from their star. That's the Dyson sphere level. Type 3 can use energy from an entire galaxy. Think Dyson spheres around every star and even extracting energy from black holes. Right now, Earth's civilization ranks about type 0.7449, give or take. That means that we haven't even maxed out the energy available to us on Earth, including fossil fuels, renewables, and nuclear power. We're still taking baby steps on this cosmic scale. Anyway, the problem with the theory that our perfectly shaped object could be a Dyson sphere is that this example of super advanced technology would give off heat. In other words, there would be thermal infrared radiation, and the object would be unusually bright in the infrared. This could be a sign that something artificial is absorbing the star's energy and re-emitting it as heat. But the scientists have found no heat signatures or anything like that when observing Teleos. So, do we have the final answer? Not yet. The scientists have looked at all the existing clues: how bright the thing is, how big it looks, and how far it might be. And none of the possibilities are totally perfect. Each idea has a problem, especially the fact that we're not observing any X-rays, which should be there according to the usual rules. They still think that regular type LA supernova idea is the best bet for now, but they're not 100% sure. There's just not enough proof to say for certain. So, the mystery continues. The team says we'll need more powerful and detailed observations to really figure out what happened here. But in any case, if something like Teleos can exist, what else is out there, waiting to challenge everything we know about the universe? Psst, a giant is hiding in the sky. Kipoo is the biggest thing we've ever found in the nearby universe. It's been messing with our understanding of the universe for years, and we've just discovered it. Kipoo is dense, powerful, and dangerous to ignore. If we don't understand structures like this, we might be reading the universe completely wrong. So, what exactly is it? It's not a solid object like a planet or a star, and it's not a single thing. It's a superstructure, basically an entire region of the universe, a tangled mess of matter spanning a huge amount of space stitched together by gravity. Kipoo is made up of an enormous web of galaxies, galaxy clusters or giant groups of galaxies, gas and dark matter. It's like a superhighway, with galaxy clusters being the cities, filaments being the roads, and dark matter being the invisible infrastructure holding it all together. This giant stretches across 1.3 billion light-years. That means if you traveled at the speed of light, it would still take you 1,003,000,000 years just to cross it. Kepoo also holds 200 quadrillion solar masses, even though it only takes up 13% of the observable universe. The name Kepoo comes from the Incan system of knotted cords used to record things, called quipu's. It was like a writing system. In that system, each knot, color, and twist told a story – numbers, taxes, harvests, and so on. So, when astronomers saw this colossal structure in space, long, tangled, and branching like space cords, they named it after this language of knots. Plus, the shape of the space reminded scientists of those threads. There's a long central filament, and the smaller ones are branching off the sides. What's even more fascinating, Kepoo isn't alone. When scientists mapped this part of the universe, they found 5 of these massive structures. They aren't just sitting there either. They formed over billions of years through gravity slowly pulling matter together. All told, all those giants hold nearly half of all the galaxy clusters in that region, 30% of all the galaxies, and a quarter of all the matter in the observable universe. The team that found Kepoo used a clever trick. They searched for X-rays coming from galaxy clusters. These clusters aren't just full of galaxies, they're also filled with superhot gas. That gas is so hot it glows in X-ray light, which we can't see with our eyes, but special telescopes can. If there's a lot of that X-ray glow, it means there's a huge amount of matter, galaxies, gas, and dark matter all pulled together by gravity. That's where the densest, most crowded areas of the universe are. So, by following the X-ray glow, the scientists could draw a map showing where the biggest cosmic structures like Kepoo were hiding. Why does any of this matter? Because these megastructures mess with everything. First of all, they warp the cosmic microwave background, the ancient light left over from the Big Bang. It's a faint glow of light that fills the entire universe. After the Big Bang happened and our world was created, it emitted its very first light and signals that still haven't completely weakened yet. The leftover radiation is still coming to us, even after 13.8 billion years. By studying this ancient light, scientists can learn what the early universe looked like, and Kepoo ruins it for us. These megastructures hold so much gravity that they bend and distort this ancient light as it passes through them. That's called the integrated Sachs-Wolf effect. These warps add noise to the original signal, and now it's harder for us to get a proper, clearer understanding of what the baby universe looked like and how it expanded. They also mess with the Hubble constant. The universe is constantly expanding, and the Hubble constant tells us how fast it's growing. In other words, how quickly galaxies are moving apart from each other. But giant things in space, like Kepoo, have so much gravity that they pull nearby galaxies toward them, messing up the way those galaxies move. This makes it harder for scientists to measure the universe's true speed of expansion. They can't tell if a galaxy is moving because of the universe growing or just because it's being pulled by something huge nearby. And finally, there's gravitational lensing. Light in space travels constantly, but it doesn't always follow a straight line. If the space gets distorted, like by gravity, then the light traveling through the space will get bent and distorted too. Gravitational lensing is when light from faraway galaxies gets bent because it passes by something supermassive, like Kepoo here. That huge gravity pulls on the light, like how a heavy ball can bend a sheet. And since light delivers information to us, literally makes us see what things look like, this bending distorts how we see galaxies. The images of galaxies end up looking stretched, brighter, or we can even find an entire galaxy in the wrong place. It's like looking at our universe through a warped magnifying glass. If we're not careful, we could misread those distortions and get the wrong idea about what our world looks like. Luckily, we didn't just drop these mysterious superstructures out of nowhere. Astronomers suspected that something like that should be out there. They just didn't know for sure. Our best model for the universe is called Lambda CDM. It says, universe started with the Big Bang, is still expanding, and is mostly made of mysterious stuff, dark energy, and cold dark matter, the CDM part. We can't see or touch these things, but we know they exist, because if they didn't, our universe would literally break apart. This model matches what we do see, like galaxies forming, how stars move, and the overall shape of the universe. So even if some puzzle pieces by themselves are still a mystery, they match the actual picture. And this model actually predicted things like Kipoo. When scientists ran simulations using that model, they saw similar structures forming, giant cosmic webs of galaxies tied together by gravity. Kipoo matched those predictions in real life. This also means that Lambda CDM is matching real life once again, thank heavens. No huge surprises here. But now that we actually found it, it's the largest known structure in the observable universe. There was another giant before Kipoo, the Sloan Great Wall. That one was discovered in 2003 and was believed to be one of the largest structures ever found. And it's still an absolute monster. The Sloan Great Wall stretches over 1 billion light-years across. It's called a wall, but it's not like a wall you'd find on Earth. It's also a vast cosmic web, made up of thousands of galaxies and gas connected by dark matter. What makes both Kipoo and the Sloan Great Wall so surprising is that they literally seem too big to exist. According to the Lambda CDM model, structures that huge shouldn't be common, especially at the time they formed. How did these giants form so fast in a universe that's supposed to be growing, expanding, and smoothing over time? And if we keep finding more of them, that would be completely insane. It could mean there's something deeper going on in the way our world is built. It's all part of our crazy Copernican journey, a long series of discoveries where we just keep getting humbled by the universe. Every time we find something like this, we realize even more how we're not the center of everything. First, we learned the Earth wasn't the center of the solar system. Then we found that the solar system is just one speck in a galaxy. Now, even galaxy superclusters, which we believe to be the biggest, are being dwarfed by structures like Kipoo and the Sloan Great Wall. But also, these structures won't last forever. Kipoo is temporary. Over billions of years, gravity will tear it apart, breaking it into smaller pieces. Some parts will collapse into tighter clusters, others will drift apart. Right now, though, it's one of the most important structures in the known universe. It shapes how galaxies form. It bends light, making it super important for us to decipher. It literally messes with our understanding of the cosmos. So astronomers have spotted about a dozen mysterious explosions in space, and no one really knows what they are or why they're happening. At the moment, they occur about 200 million light-years away. But what if, one day, they get much closer to our planet? Now, this all started back in 2018. One day, telescopes saw a giant boom far away in space. That explosion was incredibly bright, about 100 times brighter than a normal star explosion, called a supernova. The strange thing was that normal supernovae take weeks or even months to fade away. But that one went from kaboom to poof, gone, in just a few days. It got extremely hot and huge, about the size of our whole solar system, and then vanished like it never happened. Scientists were seriously confused. Now, they named the explosion the Cow, because its official name was too long and not exciting at all. Since then, astronomers have been hunting for more of those oddball explosions. And indeed, they've found a few more and given them weird animal names too. That's how we got the koala in 2018, the camel in 2020, the Tasmanian devil in 2022, and the finch, or the fawn, in 2023. All of those are part of a strange group called LFBOTs. That stands for Luminous Fast Blue Optical Transients. Luminous means they're super bright. Fast because they happen and disappear really quickly. The blue color results from their temperature. They're super hot, like 72,000 degrees Fahrenheit. And optical transients means they show up in visible light and don't stick around for long. Even now, the scientists are still scratching their heads, trying to figure out what's causing these bizarre space flashes. It's like the universe is playing a mysterious game, and no one knows the rules yet. At first, scientists thought those space explosions were failed supernovae. That's when a star tries to explode but instead collapses in on itself, kind of like a balloon popping inward. That collapse can create a black hole in the middle that will eat the star from the inside out. But recently, a new theory has popped up, and it's even cooler and creepier. It has to do with black holes, super squished leftovers from exploded stars. They're so powerful that even light can't escape their clutches if it gets too close. That's why they're totally dark and impossible to see directly. Now, some space scientists think that unknown black holes, not too big and not too small, might be pulling in stars that get too close, which produces those explosions. Such holes are called intermediate mass black holes, and no one has actually seen one of those yet. They're like space's biggest mysteries, and we'll try to solve it in a few minutes. But after that, you need to know that a new left-bot has shown up in space. It was spotted by a telescope in Liverpool and is currently called AT 2024 WPP. Yep, scientists still haven't picked an animal name, but they're thinking maybe the wasp. What do you think of this name? Share it in the comments. Anyway, one of the scientists is sure that it's the best one since the cow. The most recent space explosion is super interesting and extremely bright, like me. Maybe the brightest one since this whole left-bot thing began in 2018. This new WASP boom also doesn't look like a failed supernova. And still, scientists are checking all the data just to be sure. Now, scientists are pretty sure mid-sized black holes that could cause the explosions must exist somewhere. It's like knowing a secret creature might be hiding in space, but no one has gotten a photo of it yet. Some scientists think that this idea is the most exciting, and that it might even help explain dark matter, one of the biggest mysteries in the entire universe. Well, whatever the truth is, a recent discovery might shed light on the existence of mid-sized black holes. The thing is, when it comes to black holes, space has a few different sizes – small, super huge, and something in the middle. The small ones are called stellar mass black holes. They're around 5 to 50 times heavier than our Sun. The giant ones are called supermassive black holes. Makes sense. They're millions or even billions of times heavier than the Sun. They usually hang out in the middle of galaxies. And then there's the mysterious kind in between, called intermediate mass black holes. Those are like the missing link of black holes. Scientists are pretty sure they should exist, but we barely know anything about them, like where they came from, how they grow, or what they're made of. Good news, that mystery might finally be getting solved. Thanks to several new studies, scientists now have some exciting new clues. Researchers have found waves in space, which are called gravitational waves, that seem to come from black holes smashing into each other. And not just any black holes, but ones that are 100 to 300 times heavier than the Sun, which may mean that they're those mysterious mid-sized black holes. Plus, those are the biggest black hole collisions we've ever recorded on Earth. Now, black holes are like space fossils, super old history clues. And those newly discovered black holes could tell us about the first stars that ever lit up the universe. The problem lies in the fact that our tools on Earth, like LIGO, which stands for Laser Interferometer Gravitational Wave Observatory, only catch a tiny moment of these black holes crashing together, literally just a split second. That makes it tough to figure out where those medium-sized black holes come from. So, scientists have a new plan. One scientific lab is getting ready for a future space mission called LISA, short for Laser Interferometer Space Antenna. It's a cool space project by NASA and the European Space Agency, launching in the late 2030s. LISA will float in space and be able to catch the whole story of black hole crashes, not just the final boom. It will track black holes years before they crash into each other. And, if all goes well, we might finally figure out where these mysterious black holes come from and learn even more about how our universe began. So you might be wondering about how LISA will do it. Remember we talked about ripples dashing through space called gravitational waves? Black holes crashing into each other could send them out. Well, LISA is being built to listen for such waves. It'll float in space and look for all kinds of cosmic shakeups, Not just huge ones, but also smaller black holes spinning around giant ones. Now, why do gravitational waves matter? A lot of space stuff is too dark to see with regular telescopes, since no light comes from it at all. But gravitational waves don't care about light. They go through everything, telling us about the secrets hiding in the dark parts of the universe. By studying them, scientists hope to learn about things we've never seen before, like black holes, or what really happened at the very start of the universe, and maybe even things we don't know exist yet. Lisa will help us figure out how the universe began, how it's changing, and what it's made of. Now, getting back to those black hole collisions, finding them isn't easy. But researchers have come up with a smart solution. They're using artificial intelligence to make sure the signals from space aren't messed up by noise from Earth or the machines themselves. This work was part of a project focused on combining AI with space science. Scientists are getting more confident that intermediate mass black holes, the ones in between small and supermassive, are real, and they might be some of the most exciting things we can study using gravitational waves, both from Earth and from space. So the next big step? Looking to the Moon. Future detectors placed on the lunar surface could be even better at catching certain types of space waves, especially ones that Earth-based machines might miss. That would help scientists figure out where those black holes dwell in space. Besides this research, scientists are also planning human exploration of the Moon. They're helping NASA choose the best spots for future missions, focusing on big science goals like solar physics, space weather, and how the universe works. Right now is a super exciting time, not just for studying black holes, but also for connecting space exploration and science.
In a star system far, far away, to be more precise, 2,600 light-years away, there's an exoplanet called Kepler 1658b. It's a gas giant that resembles our Jupiter. But what differentiates it from Jupiter is that this poor planet is doomed. It's spiraling toward its parent star, which will eventually end in a fiery collision. But the most interesting thing? Astronomers would have remained totally ignorant of this fact, if not for a tiny clue. It was a really minuscule change in the planet's orbit. It wouldn't have been noticed if astronomers hadn't compared more than a decade of data received by different telescopes. More precisely, scientists have been watching the exo-Jupiter pass between our planet and its parent star once every 2 weeks for the last 13 years. And they've noticed that the orbit of the planet is getting smaller and smaller. Every year, Kepler 1658b needs 131 milliseconds less to complete a lap around its star. If this tendency continues, the planet is bound to collide with its star in 2.5 million years. Even before this discovery, computer models predicted that some planets could meet their end by crashing into their stars. But this is the first time when astronomers have some real proof of such an outcome by measuring almost imperceptible changes in a planet's orbit. They now know for sure what happens when a planet is going to crash into its star, even though we probably won't be around to witness it. But let me tell you a bit more about the doomed planet. It was discovered by NASA's now retired Kepler Space Telescope. It was launched in 2009, and its mission was to find planets orbiting other stars, aka exoplanets. And the very first exoplanet the telescope spotted was the very gas giant we've been talking about. But it took astronomers about a decade to confirm that this space object was indeed an exoplanet. This world is like a denser version of Jupiter. I mean, take 6 Jupiters worth of material, roll it into a ball about 1.1 times as wide, and voila! The planet is tidally locked to its parent star, which means that it makes one complete turn every time it finishes a lap around the star. As a result, the same side of the gas giant is always facing the star. It's the same as what happens to the Moon. Our natural satellite is tidally locked to Earth. That's why we only see half its surface. Now, what is making the exo-Jupiter fall into its star? The same process that is pushing the Moon away from Earth. When a moon orbits a planet, or a planet orbits a star, their gravity forces interact and tug on the other's mass. That's what causes tides on Earth. This tugging releases some energy. It can make an object speed up and slow down. In the first case, a space body will move higher. In the second, it will start moving lower. And this is exactly what's happening to the gas giant. Its parent star is 1.5 times the mass of the Sun. So, no wonder its tidal forces are gradually slowing down the planet's movement, making it fall inward. This all sounds kind of tragic, but this potential collision is by far not the weirdest thing happening in space. Let's look at some others. For example, Betelgeuse, a red giant in the Orion constellation, started to dim in 2019. This confused astronomers. By that time, the star had already swollen to enormous proportions. If it was to replace our Sun, its outer surface would spread far beyond Jupiter's orbit. And then Betelgeuse became dimmer in the fall of 2019. This process continued through February 2020. The changes could be seen with the unaided eye. No wonder, the star's brightness had dipped by 2/3. At that time, astronomers were sure Betelgeuse was about to explode into a supernova. They continued to observe the star, but unexpectedly, it returned to its regular brightness. Thanks to the Hubble Space Telescope, scientists figured out that the star had ejected some of its material, and this partially blocked its light. How about cotton candy exoplanets? Those are particular planets outside of our solar system. Also called super puffs, they have the lowest density ever discovered. This gives them an airy, fluffy appearance. But despite looking like the most popular amusement park treat, such planets are enormous. Come to think of it, scientists often discover strange things in space. Some of them look like blurry blobs. But there's one type of these blobs that doesn't look like any other known space body. The odd radio circles are only visible in radio telescopes. They might be the remains of supernovae, but some astronomers go as far as to claim that they might be the throats of wormholes. Those are hypothetical tunnels between two very distant points in space. The Juno mission noticed something weird in the upper atmosphere of Jupiter. The unusual phenomenon was blue sprites and elves twirling above the planet's surface. These are two kinds of bright flashes of light that appear for short periods of time, mere milliseconds. They extend up and down toward the surface of the planet. On Earth, such flashes usually happen at the height of 60 miles above massive thunderstorms. Rogue planets don't orbit their stars, maybe because they don't have any. These free-floating space bodies travel across the universe and can end up literally anywhere. They're also pretty hard to find. Rogue planets produce only weak emissions, but not so long ago, astronomers spotted the smallest rogue planet in the Milky Way. It's smaller than Earth, but a bit bigger than Mars. Fast radio bursts are blindingly bright bursts of radio waves. They pack as much energy as our Sun produces in days, but last mere milliseconds. Most of these fast radio bursts come from far, far beyond the Milky Way. But recently, astronomers have detected some originating in our home galaxy, and their source is a magnetar just 30,000 light-years away from our planet. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. Not so long ago, scientists discovered that one of the most massive stars in the neighborhood had just disappeared. It was a star 75 million light-years away from Earth. Normally, it'd be too far away for astronomers to clearly see individual stars, but only unless they're huge. And the star we're talking about was enormous. It was shining 2.5 million times brighter than the Sun. For the last time, astronomers saw the star in 2011. They decided to examine it more closely several years later, but it was already too late. The star had vanished. Such massive stars usually go out in extremely bright supernovae, but astronomers noticed nothing like that in this case. There's a theory that the star collapsed into a black hole without triggering a supernova first. It does occur among stars approaching the end of their lives, but very, very rarely. There are black holes And there might be mini black holes, even though their existence hasn't been proven yet. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Their mass can vary, but just one minuscule thing might have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. More than 7,000 light-years away from Earth, there is the Eagle Nebula, a young cluster of stars just 5.5 million years old. The Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. Those are the so-called pillars of creation, an active star-forming region. Look, how cool is that?
Now imagine something so powerful that it could rip the atoms of your body apart in a fraction of a second. Ow! This something is soundlessly dashing through space, not extinct, not alive, stuck in between. If this terrifying monster were moving towards Earth, we'd be doomed. So, is it? Astronomers have found a fast and powerful space object zooming through our home Milky Way galaxy at over 110,000 miles per hour. That's faster than any rocket we've ever made. This bizarre space object got its name of a zombie star, all because it's the leftover part of a star that passed away a long time ago, but is still moving. This zombie star is a kind of an object called a magnetar, a super small, super heavy ball about the size of a city but heavier than the Sun. That makes it one of the densest objects in space. Only black holes are denser. Hey, let's not forget about me, huh? Magnetars also have an incredibly strong magnetic field. The one our zombie guy has is 100 trillion times stronger than Earth's. That's so strong that if the magnetar came close to Earth, it could wipe out every credit card on the planet just from its magnetism, and we couldn't shop anymore. Plus, if a person got too close to a magnetar, like 600 miles or so, it could pull their very atoms apart, and they couldn't shop anymore. Luckily, this magnetar is very far away and not coming near us. When it was first discovered, it was about 15,000 light-years away from Earth. That's a huge distance, so you don't get to worry about your atoms being disconnected yet. Astronomers first spotted the zombie magnetar in 2008. And since only about 30 magnetars are known in our galaxy, it was a lucky and rare find. Scientists use space telescopes like Hubble and Gaia to watch it over time. That's how they discovered it was moving much faster than they thought. Now, astronomers are trying to figure out how this zombie star got such a big kick. At first, they thought that, like most magnetars, this one was born when a giant star exploded in a supernova and the leftover core became a super-dense neutron star. According to their theory, it could have happened near something called supernova remnant HB9. That would make sense since most magnetars are created this way. But when they tracked its movement, they found that the zombie star was moving too fast and going in the wrong direction to have come from HB9. They traced its path thousands of years into the past and still couldn't find any exploding star or star cluster it could have come from. This means scientists now have one more mystery on their hands. Where did this zombie star come from, and how was it made? One explanation is that it came from a white dwarf, which is the leftover core of a smaller star like our Sun after it runs out of fuel. Now normally, when white dwarfs explode, they're destroyed completely. But in rare situations, instead of blowing apart, a white dwarf might collapse into itself and turn into a neutron star. This neutron star could then become a magnetar. This unusual way of forming a magnetar also gives clues about another mystery: fast radio bursts, or FRBs. These are very quick and powerful flashes of radio energy from deep space. Some FRBs come from galaxies that are so old there shouldn't be any exploding stars left. But if magnetars can be born from collapsing white dwarfs, that might explain how those FRBs are still happening. In any case, learning how magnetars form could help us explain many strange and powerful events we see across the universe. But so far, the investigation is still on, and no answers have been found yet. Zombie stars wandering across the universe isn't the only mystery we haven't solved yet. At one point, you might come across one of them while traveling through the cosmos. It looks like nothing. At a distance of 700 million light-years away from Earth, there's a hole, a blank void that has very few galaxies. This is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there thousands of times over. It's the mysterious Bode's void in the constellation of Bodes. Yeah, makes sense. You see, galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters. But between these clusters and threads, there are huge, empty voids that hardly contain any galaxies. Such voids make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bode's void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, I wasn't around then, all the matter in the universe was packed together quite tightly. Astronomers even thought it was something like a uniform soup. But soon, random quantum fluctuations started disturbing this matter. Some areas became denser, and their gravitational pull became stronger. They began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. If you visited a star cluster called Palomar 5, you'd forget all about voids and supervoids and even zombie stars. Instead, you'd need to concentrate on surviving, since the region is hiding a swarm of over 100 black holes right in the middle. And those black holes aren't just sitting there, they're at work, shaping the cluster nonstop. Palomar 5 is a group of stars located about 80,000 light-years away from us. Normally, clusters like this are dense and tightly packed, with stars all bunched up together. But Palomar 5 is different. It's spread out and has a huge tail of stars stretching across 30,000 light-years. This beautiful tail is called a tidal stream. It's like the stars are spilling out of the cluster, creating a long river of light. Tidal streams like this are rare and hard to study. Globular clusters like this one are super old. Some are almost as old as the universe itself. But Palomar 5 also stands out because it's the only cluster we know about that still has a tidal stream attached to it. And the black holes inside the cluster might be to blame. They're pulling on the stars in the cluster, messing with their orbits, and slingshotting them right out of the cluster. Or would that be slingshooting? I don't know. Anyway, these stars are what make up the tidal stream. Over time, more and more stars get flung out. Palomar 5 has way more black holes than expected. About 20% of the cluster's mass is made up of black holes, over 100 of them, each about 20 times the mass of our Sun. Of course, Palomar 5 isn't going to last forever. In about 1 billion years, the cluster will completely fall apart. By then, all the stars will have been gone, leaving behind just the black holes. And these black holes will orbit the Milky Way, like a ghostly remnant of a cluster that used to be there. Even though this cluster is creepy enough, there's something even more eerie you can see in space: thick clouds of gas and dust called nebulae. One of the most unusual ones is probably NGC 2392, located 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and became popular because of its unusual appearance. It's basically a disk of material with a ring of comet-shaped objects. The tails of these objects stream away from the star at the center of the nebula. The bizarre orange streaks in the outer part of the cloud stretch light-years away in all directions. The middle resembles a ball of twine, but in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Wow.
Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have had been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plait thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? All right, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but For real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon, summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?
So imagine that ChatGPT will start perceiving itself as a person and will feel emotions in a few years. Many people are afraid that it will want to take over the planet. However, this fact won't be as important as the question people will start asking themselves at that moment. If humanity has created a machine with self-awareness, then could it be that humanity was also created artificially? Now, artificial intelligence lives on the internet, computers, and in digital reality. But what if we also live inside a huge, powerful computer? What if our universe is just a simulation? The most extraordinary thing is that some facts seem to point to this. There's a whole science in the world that studies this theory. It's called information physics, and it assumes that time, space, and matter are not fundamental natural phenomena, but bits of information. This information forms a picture that creates the laws of physics for us. For example, we feel cold and warm not because atoms get cold or warm, but because their movement accelerates or slows down. The speed of particles can be like bits of information. Billions of them could form the picture of reality. Once, philosopher Nick Bostrom said that an advanced civilization could create such complex technologies that simulations of these technologies would be indistinguishable from our reality. And Elon Musk said in 2016 that we were most likely in a simulation. Wow. The laws of physics resemble a giant code that programmers write when creating apps or games. For many of us, all these complex trigonometric equations and formulas of the laws of physics are too complicated. Tell me about it. But scientists who understand this issue see that the principal workings of these laws are beautiful, and this may suggest that someone deliberately created this beauty. Virtual worlds, apps, or games are based on information processing. If you delve into this information, you'll see that it consists of bits and pixels. Any picture on your phone screen is pixels, and any file transfer process is based on bits. They add up to bytes, kilobytes, megabytes, and so on until a bigger picture is formed. And if our life is a simulation, it must also consist of bits. In our case, pixels and bits are atoms and other particles that make up our universe. There are processes inside your computer and phone with maximum speed limits and computing power. If you start exceeding it, then your device will start working more slowly. So, in our reality, there is also a maximum speed limit. This is the speed of light. When an object starts moving almost as fast as the speed of light, time slows down for that object too. Also, time flows more slowly near a black hole. This object, with an unimaginable gravitational mass, can be something heavy that overloads the processor's computing power. There's also such a thing as quantum entanglement, in which two particles can be connected even though they're far away from each other. Electrons travel around an atom. They are connected, and if the property of one changes, the second one will react. And even if you place these electrons on different sides of a galaxy, they will retain this connection. How is this possible? Scientists don't know. A double-slit experiment is one of the most famous experiments that hint that our world is a simulation. The existence of this experiment can be reduced to a simple thesis that the world exists only when we look at it or interact with it through touch, hearing, and other senses. So imagine that you've launched a new game on an old computer. Sometimes the game map freezes. In the game, you turn to the left and see how the mountains and the roads are getting loaded. Then you turn to the other side and the same thing is happening there. In other words, the world in the game only loads when you look at it through the eyes of your character. This is necessary to facilitate the work of the processor. It's much more efficient to get a piece of information about the world when you look at it than to keep the whole world running simultaneously. Remember this. And now let's move on to the experiment. So, you have a device that fires small balls of light, photons. You release photons from the device and they crash into a blackboard, leaving white traces on the black surface. Now, put a wide plate with a little vertical slit on it between the device and the blackboard and fire photons again. The balls start crashing into the plate, but some of them fly through the thin gap. They smash into the blackboard and leave a vertical white mark on it. Everything looks quite logical, but now cut another slit with the same length and thickness in the plate. You release photons toward the plate. Some of them fly through the two slits. What do you think the trace on the board should look like? Two white vertical stripes, right? Well, take a look at the board. It's covered with many vertical lines. When photons pass through the plate, they acquire the properties of a wave and crash into the board, leaving a strange trail as if they've passed not through 2, but through 10 slits. So, at what point do they change their trajectory? Let's take a look. So, you stand between the board and the plate to see how particles turn into a wave. The device releases photons. They are passing through the two slits. Nothing unusual. There are two vertical traces on the board and no waves. You close your eyes and release photons again. This time, they behave chaotically and leave many lines on the board. That is, their behavior changes depending on the observer. When you look at them, they behave logically. But when you don't look, the laws of physics seem to stop working. Does it remind you of anything? It's like you're playing a game and looking at the world around you, which is loading. But if you don't look, the world stops working. Scientists still don't have a clear explanation of why particles behave differently when there's no observer. Hey, maybe they're shy. And this is not the only mystery. In the world of quantum physics, many laws of nature don't work. This is a science that gets more questions than answers every year. If we imagine our universe as a large hologram, then quantum physics would be its program code. What if people someday understand this code and learn to change it? This would allow us to transform space, time, and matter. The whole reality could be rewritten. Does the code say that material objects can't exceed the speed of light? We would rewrite it and make the speed limit 100 times higher. Does 1 hour last 60 minutes? What if you change one line of code and make 1 second as long as 1 year? A few software changes in the laws of physics would make it possible to turn snow into gold and the ocean into powdered sugar. The whole universe would turn into a vast playground. It seems cool at first glance, but people would probably lose control soon. The universe would be in chaos, and the beauty of our world is in the order that exists here. Now let's go back to artificial intelligence. Suppose its power reaches the level of the human brain, and it will become aware of itself. In that case, it won't come as a shock to it because it will most likely know the history of its appearance and stages. But how will we react if people discover they are a computer program? A computer program is too simple a word. A human is a complex, intelligent, multifunctional organism that experiences emotions, contemplates beauty, has abstract thinking, and much more. The term creation is more appropriate here. It won't matter if we were created artificially because our creation will still be beautiful and complex. Besides, remember that good video games or apps can be made only if developers love their creations. Oh, fasten your seatbelts. We're setting course for the most bizarre places in our universe, and you'll see the most mysterious phenomena few people have ever seen before. Recently, astronomers have discovered that the supermassive black hole at the center of our home Milky Way galaxy might be leaking. Why is it a significant change? Because it might mean that this black hole, called Sagittarius A star, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active. And the leakage, recorded by scientists, may be the hole hiccuping while swallowing clouds of gas. Hey, I've been known to do that from time to time. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often occurs around other active black holes surrounded by the material drawn to them by their immense gravitational pull. Some of this material gets pulled into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches small jets of matter. Fermi bubbles might be the result of the belches that occurred around 2 to 4 million years ago. But recently, scientists have found another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light-years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now, let's visit some other breathtaking places in our universe. But be careful, some of them are extremely dangerous. Like this rotating neutron star called the Black Widow pulsar. Just like its spider namesake, it's munching on its partner, a lightweight brown dwarf star. The more material this pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. How about visiting a planet where it rains glass? Nah, I'd rather not. You see, this bright blue exoplanet looks peaceful and slightly familiar. Don't you think it slightly resembles Earth? But this pretty appearance hides the planet's terrifying nature. The winds blow at 5,400 miles per hour on its surface. That's 7 times the speed of sound. But that's not the worst. It rains glass sideways in this scorching hot alien world. Solar tsunamis are a solar phenomenon dubbed Terminator events. These tsunamis take place at the sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen every decade or so. Now look at this space body. Its nickname is Electric Hyperion. This Saturn's moon is one of the most bizarre-looking moons in the solar system, but its appearance isn't the strangest thing about it. This pumice stone-like rock, pockmarked with countless craters, is also charged with static electricity, and it's flowing out into space. Look at this, a rogue planet with auroras. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars. But one of them, 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates flashing auroras in the planet's atmosphere. Be sure to stay away from black holes. Do I really need to warn you? Yep, they're some of the most perilous objects in the universe. But how about mini black holes? Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. Ooh, I'll bet you like our next stop, a burning ice planet. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means it's traveling remarkably close to its parent star. That might be the reason the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X, which remains solid despite blistering temperatures. Now, if you love jewelry, this next world is for you, a diamond planet. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. This in turn might mean that at least some part of the planet is diamond. Moons orbiting other moons might exist, or they might not. Astronomers haven't agreed on this one yet. Planets orbit stars, and moons orbit planets. But then, why can't there be moons, also known as submoons, moonettes, and moons? It actually sounds like one of those flowery Hawaiian dresses, moo-moos. But alas, no. Researchers claim that moons could exist, but the host moon has to be massive enough, the moon small enough, and there must be a wide gulf between these moons and the host planet. Now, I'll take you to the living fossil galaxy. DG-SAT-1 is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that DG-SAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, this galaxy is a real living fossil. Now, you won't be able to see the next space phenomenon, all because people can't see infrared light. And the phenomenon I'm talking about is an infrared stream from space. Ooh. Neutron stars are ultra-dense collapsed cores of giant stars. They usually emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. This signal was probably generated by a disk of dust surrounding the star, but this theory hasn't been proven yet. Behind the orbit of Neptune lies the mysterious Kuiper Belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding from our sight a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. Let's visit our star, but we need to be careful not to come too close, because the Sun's atmosphere is hotter than the surface of the star. While on the surface, the temperature reaches 10,000 degrees Fahrenheit. The upper atmosphere heats up to millions of degrees. Scientists suspect that explosive bursts of heat from the Sun may have something to do with this unique phenomenon. Now, this space object is also worth visiting. Haumea, a dwarf planet orbiting in the Kuiper Belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning big object in our solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile-wide ring circling it. Ring-a-ding-ding.
When astronomers started a project that was organized to create a detailed 3D map of our galaxy, they didn't expect to find anything surprising. But that's exactly what happened. Earlier in that year, Harvard scientist Dr. Anna Bonacca noticed a weird disturbance in our galaxy's stellar streams. A stellar stream is a line of stars that are moving together through galaxies. The stellar stream we're talking about is called GD1, and it's stretched in an impressive line across our sky. This stream used to be a cohesive line, stretched by the gravity of our galaxy. One day, Dr. Bonacca noticed a gap in it, and this gap had a strange, ragged edge. In fact, it looked like something terrifyingly huge recently plunged through the stellar stream. The sheer force of this object's gravity was so great that it managed to drag stars in its wake. The most shocking thing was that the telescopes simply failed to find the source of the damage. But then, what could this unseen bullet be? One theory suggests that the intruder is a stray star. But, according to Dr. Bonacca, the hole is way bigger than any existing star. It'd have to be 1,000,000 times more massive than our Sun. Okay, so what if the hole in the Milky Way was torn by a supermassive black hole, like the one that dwells in the center of our galaxy? If these 2 black holes got too close, they wouldn't be able to escape each other's gravity. A collision might be inevitable. Then the stronger of the 2 holes would consume the weaker one, and one huge, super mighty black hole would appear. But people have yet to witness a collision of black holes. Plus, scientists can't predict the consequences of such a merge, even though they've simulated it on powerful computers. The only obvious fact is that it would produce incredible amounts of energy. Huge ripples would travel through the entire universe, bound to hit our planet eventually. Then again, 2 black holes in one galaxy might refuse to merge. Imagine this. A supermassive black hole hundreds of millions of times the mass of the Sun is spinning in the center of the Milky Way at a phenomenal speed. Another spinning black hole approaches ours. What do you think will happen? Right, one of the holes, most likely the intruder, will get kicked out and sent hurtling away like a frisbee flying through space. And who can guarantee that it wouldn't head toward the Earth? Luckily for us, there aren't any supermassive black holes in the vicinity, so this theory fails to explain the mysterious bullet hole phenomenon. Dr. Bonacca still doesn't rule out the possibility that the intruder is some kind of luminous, star-like object. After tearing a hole in the Milky Way, it could be hiding somewhere in the galaxy. But again, it seems highly unlikely because of the object's huge size. I mean, we're talking 30 to 65 light-years across. In any case, it's hard to predict where it would have ended up if it were a luminous object. The intruder could have been moving at an incredibly high speed and wouldn't have to be very massive to tear a hole in the stellar stream. Or it could have been moving more slowly, but be very heavy. But the astronomers don't know which option it was. That's why it's next to impossible to predict where it ended up.
Scientists were looking at a list of gas clouds when they saw something strange. 5 groups of blue stars that are not quite a galaxy and not a known type of star cluster either. These groups of stars are called blue blobs, and they're located in the Virgo galaxy cluster. Now, the big question is, how did these blue blobs form if they don't have any nearby parent galaxy where they could form? Scientists realize there are some heavy metals present in these blobs. Generally, when stars are born, they create heavy elements called metals. These metals are essential building blocks for new stars. In big galaxies, many stars form over time, and as a result, more metals get created too. These heavy metals in the blue blobs were a clue that the stars in these blobs were formed from gas that was stripped from a larger galaxy. Think of it as a piñata. The candy is the gas, and the piñata is this bigger galaxy. The blue blobs are the leftover candy that was scattered around. Wow, didn't expect to get hungry while talking about stars. How did the gas get stripped away from the bigger galaxy anyway? There are two ways. When galaxies pass by each other, their gravitational attraction can cause gas to be pulled away from one galaxy and into the other. This is called tidal stripping, and it's the first way these blobs can happen. It's like when two magnets attract and pull metal objects toward each other. Another way is ram pressure. This happens when a galaxy moves through a cluster of hot gas at a pretty high speed. The gas in the cluster can push against the gas in the galaxy and force it out back, similar to a car pushing air out of the way as it drives, and you lose your hat in a strong wind. As time goes by, these stars in the blue blobs will keep on moving apart. Eventually, they will form smaller clusters. Have you ever seen pictures of Earth taken from space? They're amazing. But have you seen the one with two blue blobs of light? The first blob of light you see here is a large lightning strike in the Gulf of Thailand. It's rare to see lightning from space because of all the clouds, but this one was so huge it lit up the clouds around it like some kind of a brilliant ring. How cool is that? The second blue blob of light is a bit different. We're looking at the reflection of the moon's light on our home planet. The moon actually reflects the light coming from the sun onto the Earth. And when that light goes through the Earth's atmosphere, it creates a big blue blob with a fuzzy outline. It's like a shiny blue hat our planet is wearing. It's similar to the reason why the sky is blue during the day. When sunlight enters Earth's atmosphere, gases and particles in the air scatter it in all directions. Blue light has the shortest and smallest waves, so it gets scattered the most. And that's why we get to enjoy a beautiful view of a clear blue sky. The same thing actually happens to the light coming from the moon. When it reflects off the Earth and goes through the atmosphere, the blue light waves get scattered the most, making the moon appear blue in the photo. Speaking of unusual stars, there's one in the Centaurus constellation called Lucy. It looks like a tiny white dwarf, but it's actually very dense. There's a mass of the entire sun squeezed into an object only a third of the size of our home planet. That's like stuffing a whole watermelon into a golf ball. Lucy is also incredibly cool. Its core temperature is almost 12,000 degrees Fahrenheit. This may sound hot at first, but for comparison, our sun is about 27 million degrees Fahrenheit. And the best part that makes Lucy so special is the diamond at its heart. Its carbon core has crystallized into a massive diamond that's 10 billion trillion carats in size. It's hard to even imagine how big it is. Scientists found out about this awesome diamond by listening to the star's vibrations, which is like a star's heartbeat. And after they discovered Lucy, scientists found some other stars with crystallized cores and massive diamonds the size of Earth, too. Our universe is like a giant jewelry store. Most of the astronomers from the northern hemisphere are familiar with the star named Vega. First, it's brighter than expected. But if you could take a look at it from a different angle, you'd see this star is actually squashed. It has a specific oblong shape because it rotates at a high rate. It spins once every 12.5 hours, which throws the material out around its equator. This material then cools and darkens, and forms a dark, mysterious halo around Vega. When stars reach the end of their lives, they often explode in a dazzling supernova, getting brighter and brighter before they finally fade away. But one supernova, IPF-14Ls, decided not to obey the rules. It started to fade away like most other stars, but then, when everyone expected it to be gone, it suddenly came back to life and brightened up again. And not just once. It kept fading and brightening at least 5 times in a row. Scientists were so surprised to see this. When they measured the light from the supernova, they found it was evolving 10 times slower than other stars. It was aging way more slowly, too. When it looked 60 days old, it was actually 600 days old. It could be even older, because scientists had recorded another supernova in the same spot almost 70 years ago. There are some theories as to how it could have happened. Maybe the supernova was bumping into some surrounding material and then making it glow. Or maybe it was a giant star that was shedding material all the time to prevent, or at least postpone, its own collapse. At first, it may seem like you're looking at a simple variable star here, my Camelopardalis. But when astronomers looked more closely, they realized it was a pair of stars. The two stars are moving around each other at really high speeds, and their atmospheres are starting to mix because they are so close. People believe this example is the start of a union between two stars. In the end, the two celestial bodies, which already weigh 32 and 38 solar masses each, will join together to make a gigantic one with more than 60 solar masses. Scientists have thought for a long time that this is how super big stars form. They've never really seen it happen. The universe is 13.8 billion years old, and from what we can see, one mysterious star, HD 1140283, could be 14.4 billion years old. Something's not right here. This star has all the chemical signs of a second-generation star, which is a star that formed from gas and dust after the first generation of stars exploded. This star, sometimes called Methuselah's star, is 190 light-years away. Its brightness, distance, and composition help us figure out how old it is, at least 13.2 billion years old. While the age of 14.4 billion years is probably put there as a potential range. Even if it's younger than the universe, or is it? It's still by far the oldest star near us. Let's not forget the one with a tail either. It's called Mira. Sometimes it's bright, and other times it's faint, making it a bit of a tricky one to spot in its constellation. Sometimes it's one of the brightest stars up there, while other times it is one of the fainter ones in its constellation. It's the system with two stars, a red giant and a white dwarf. The red giant used to be like our own sun, but now, as it's closer to its end, it's shedding its outer layers into space. And Mira has a comet-like tail too. As the red giant sheds its outer layers, it creates a stream of gas and dust that follows the stars as they move through space.
Now imagine a place where a single day lasts longer than a whole year. On Venus, a day, meaning one full spin on its axis, is as long as 243 Earth days. And what's even weirder, despite the fact that Venus is experiencing a never-ending day, it has a shorter year than Earth. While Earth takes about 365 days to complete one orbit around the Sun, Venus does it in just 225 days. So, somehow, for Venus, a day is more epic than a whole year. Venus is a strange planet in general. It's called Earth's twin because of how alike we are, although it's a bit smaller than Earth. But there are some drastic differences too. For example, it spins in the opposite direction, which means the Sun there rises in the west and sets in the east. And Venus isn't the only one who dances to its own rhythm. Uranus does that too. And finally, Venus is quite crazy in terms of its atmosphere. When you stand on Earth, you don't really feel the weight of the air around you. Well, on Venus, that feeling would be like having an elephant sitting on your shoulders. Venus has 90 times the atmospheric pressure of Earth. The atmosphere there is a thick layer of toxic gases. For example, carbon dioxide that's released by all the volcanoes. It presses down with incredible force. This results in very hot temperatures. No wonder it'll take a long time before we'll be able to stand on this planet. Meanwhile, Mercury, the closest planet to the Sun, has an even more speedy orbit than Venus. It completes a full journey around the Sun in just about 88 Earth days. However, it has a slow spin on its axis, which means that one day on Mercury takes about 176 Earth days, basically half a year. Just like with Venus, a day there takes much longer than a year. Since it's closest to the Sun, no wonder Mercury experiences some super extreme temperature swings. Daytime temperatures can soar up to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But wait for the sunset. At night, it drops to freezing minus 290 degrees Fahrenheit. Ooh! That's because Mercury doesn't have a thick atmosphere like we do, so the heat doesn't distribute across the planet evenly. If one side is in the dark, it'll be super cold, and the other side will be scorching hot, just like if you let a regular big rock lie down under the sun for a while. In fact, it's so cold that there might even be some ice on it. Look at the planet's north polar region, especially those sunlit yellow spots inside craters. These are indications of water ice. Turns out water is much more common in space than we thought. Mars is often dubbed the red planet. It earns this nickname from the abundance of iron oxide, or rust, covering its surface. The iron-rich minerals create a rusty red hue that paints the Martian landscape. But it turns out Mars isn't just red. If you were standing on Mars, you'd witness desert-like butterscotch terrain with caramel and golden glows, some brown, and even a glimpse of a slight greenish hue. Mars also has the biggest mountain in the entire solar system, Olympus Mons, standing at a staggering height of about 13.6 miles tall. It's even taller than Mount Everest. It was formed by the volcanic eruption yielding low-viscosity lava, creating a shield-like structure. Since Mars is covered in sand, it's also famous for its crazy dust storms. But it turns out they're even more insane than we thought. These storms can last for months. While they might present challenges for future human missions, they also contribute to the planet's mesmerizing appearance when observed from afar. And not only storms, but even its own Mars quakes. Also known as seismic tremors, they were first detected by NASA in 2019. Unlike earthquakes that are often triggered by tectonic plate movements, Martian quakes are thought to result from the cooling and contracting of the planet's interior. It's interesting how similar, yet how different the planets are. Saturn's iconic rings might hold a secret link to Earth's ancient past. The rings are composed mainly of ice particles and debris and are estimated to be relatively young in space terms, perhaps just a few 100 million years old. Now, there are some theories that propose that they were born after some catastrophic event. For example, the collision of two large moons or the breakup of a comet. What's interesting is that this timeline coincides with the age of the dinosaurs' demise on Earth. Could there be a connection? Who knows? By the way, while Saturn takes the crown for its rings, it's not the only planet in our solar system sporting them. Jupiter, Uranus, and Neptune all have their own set of rings, although they might not be as visible and cool as Saturn's. However, there's something where Saturn truly stands out: the magnificent hexagon at its North Pole. It's a colossal six-sided figure. Each side of this incredible structure measures around 9,000 miles long, which is 1,200 miles longer than the Earth's diameter. Scientists aren't sure how it was formed or why. They think it might be due to varying wind speeds, or maybe it's shaped by a localized, slow, meandering jet stream. So far, it remains another of Saturn's mysteries. Much like Saturn's hexagon, Jupiter also has its own weird spot. It's called the Great Red Spot. This is a storm that's been raging for at least 350 years and is larger than Earth itself. Despite its name, the spot's coloration has varied over the years, ranging from brick red to pale salmon. Scientists continue to study this enduring storm, unlocking the mysteries of its persistence and ever-changing hues. Meteorologically, the Great Red Spot is a powerhouse. It generates enormous pressure in Jupiter's southern hemisphere. Meanwhile, Jupiter itself is a powerhouse when it comes to magnetic fields. Its magnetic influence is colossal. It extends far beyond the planet itself and creates one of the largest and strongest magnetic fields in our solar system. Because of that, Jupiter is a source of intense radiation and mesmerizing auroras. While Earth's northern lights are breathtaking, Jupiter has something to offer too. The magnetic field interacts with charged particles from Jupiter's moons and the solar wind. This creates visually striking auroras near its poles. But compared to Earth, the scale of these auroras is incredible, like nothing we've seen on our planet. But even having a cool big spot isn't a unique feature in our solar system. A stormy giant Neptune, the eighth and farthest planet from the Sun, also has its great dark spot. Just like Jupiter, it's a massive vortex in Neptune's atmosphere. But unlike its Jupiter counterpart, this spot tends to come and go because of Neptune's dynamic and ever-changing weather patterns. Neptune, together with Uranus, is known as an ice giant, and just like other giants, it boasts some of the most ferocious winds in our solar system. Its supersonic winds can get faster than 2,200 miles per hour. What a drama queen! But this explains its thick cloud formations. By the way, if you ever dreamed of a planet raining diamonds, you might want to visit this planet. Deep within Neptune's atmosphere, where pressures are extreme, scientists theorize that carbon atoms are compressed and form diamonds. And then, these diamonds might be raining down. What a unique touch to stormy weather. Neptune's moons got from their parent with the weird weather. For example, its largest moon, Triton, has a touch of cryovolcanism. Instead of spewing molten rock like Earth's volcanoes, Triton's cryovolcanoes erupt with a mix of water, ammonia, and nitrogen. Picture it as icy geysers shooting material into space. Seems like in our solar system alone, each planet has its own quirks and interesting qualities. Let's hope that we discover some more interesting things in outer space in the future.
Do me a favor, will ya? Try to imagine the first time you went camping. Maybe you went with your parents. Maybe it happened on a class field trip with your schoolmates. Regardless, try to picture, or remember, what it felt like as the day was coming to an end. The sun has set, but there's still some light outside. Let's say you were lying down, trying to rest for a bit. What's the first thing you remember seeing when looking up? If you're anything like me, it was probably the overwhelming number of stars twinkling right before you. These stars, most of which you can see without any fancy devices, are part of the Milky Way. Believe it or not, our amazing galaxy is almost as old as the universe itself. Age aside, it's also a pretty nice place to be. The Milky Way is like a cosmic nursery where new stars are born. And let me tell you, it's home to some of the most fascinating places, at least from what we can see in pictures. Take the Mystic Mountain, an area in the Carina Nebula. Here, things are always splashing and full of energy. That's because of gas columns collapsing and creating crazy opposing jets that are thrown around like acrobats in a circus. It's like a signature move for stars being born, you know? And if you take a look at this awesome picture, you'll see the elements putting on a colorful show. Blue represents oxygen, green is for hydrogen and nitrogen, and red is the sizzling sulfur. Ready for our next stop on our ride through the Milky Way? Check out these huge, twisted clouds of interstellar dust and gas hanging out in the center of M16, also known as the Eagle Nebula. We've got ourselves the super cool Pillars of Creation, which are like towering columns where brand new stars like to hide and chill. Now, I know this ain't the first time the Hubble telescopes captured this epic sight, but trust me, this is the most mind-blowingly detailed image yet. The pillars are getting showered with crazy hot ultraviolet light from a bunch of young stars hanging just outside the frame. These stellar superstars are actually causing the towers of dust and gas to gradually get worn away by their gusty winds. Brace yourself for the numbers, too. These pillars of creation stretch out for about 4 to 5 light years. Yeah, it sounds big, but in the grand scheme of things, they're kind of like the cute little siblings of the larger Eagle Nebula, which spans a whopping 70 by 55 light years. The nebula was first spotted back in 1745 by an awesome Swiss astronomer, and it's about 7,000 light years away from our humble abode, in the constellation Serpens. Here's the quirky part though. As productive as it might sound, the Milky Way's star-forming activity is quite rare when compared to other galaxies. Astronomers have noticed that the pace at which stars are being born is actually dropping, and they're itching to figure out why. But before we can dive into this weird phenomenon, let's look at how stars come into existence in the first place. It's hard for us to know for sure from down here. What we can gather about a star's life cycle comes from looking at those within our local Milky Way. Stars are formed in colder clouds of gas and dust called nebulae. These areas are pretty common throughout most galaxies. These nebulae have low temperatures that are crucial for hydrogen gas to stick together. As the clump gathers more gas, it causes movement, which itself creates energy. When more gas collides with the already formed clump, all that energy transforms into heat. This keeps going until the temperature grows considerably, sparking the birth of a star. The most secure time of a star's life is also known as its main sequence. I'll spare you the chemistry lesson, but during this time, the star produces both heat and radiation. It's because of the radiation that there's pressure around a star, and it's also the reason for most of the light found in a certain galaxy. Now let's talk star sizes. The bigger the star, the faster it consumes its fuel. These massive stars shine the brightest, emitting high-energy UV light. On the other hand, lower mass brighties live longer, despite not being as shiny as their larger siblings. There's a variety of star sizes in most galaxies we're able to see from down here. Some stars are 0.1% the size of the Sun, while others have 10 times its mass. Once a star finishes up its fuel, it welcomes its grand finale and transforms into a faded star. Stars about the same size as the Sun or smaller can no longer produce radiation at this stage. Gravity takes over, causing their matter to settle into a white dwarf. For bigger stars, the timeline changes a bit. They too collapse, but there's a lot more stuff burning, and it's also hotter in there. This collapse creates a stronger core. When all of the star's insides are done for, the outer layers collapse in a jiffy. It bounces off the core at nearly the speed of light. It's an impressive, explosive event called a supernova. The blown-out material becomes the basis for future stars. It also leaves behind a black hole. Now that we know a bit about a star's life, let's try to look at each generation, if you'd like. Stars don't just pop up constantly at the same rate. Currently, the universe is manufacturing only about 1/9 the number of stars compared to its star-forming glory days, which happened roughly 10 billion years ago. One study gave us a peek on the history of star forming. In writing it, 2 scientists teamed up to gather a ton of data about galaxies. They sorted these galaxies based on how far away they were. By doing this, they could track how the brightness of galaxies has changed over the universe's lifetime. Since stars give off most of a galaxy's light, they could use that brightness to figure out how many stars were forming, using some fancy math. Their findings confirmed that star formation was pretty wimpy when the universe was young. But as gas started to gather in galaxies, boom! Star formation skyrocketed until about 10 to 11 billion years ago, when it hit its peak. After that, star formation took a nosedive. In today's observable universe, it's dropped a lot. That means around 50% of the stars we see today were born in the first 5 billion years post-Big Bang. A mere quarter formed in the last 6 billion years. So what's causing this cosmic shift? Well, scientists think it's all about that cold gas that stars need when they're born. When galaxies form, the gas gets concentrated inside, leading to a star formation extravaganza. But then, the gas is used up quickly as stars doze off. When supernovae come into play, they blast away that much-needed gas for future star making. Not to mention it also changes the chemistry of that gas. This crucial piece of information could be a starting point for the star-making decline we see today. Scientists are still not sure why this gas becomes useless. Galaxies are also pretty complex to begin with. There are all sorts of forces involved in maintaining their balance. For instance, when a supernova goes boom, the shock waves can sometimes cause turbulence and clumping of the gas, sparking the birth of new stars. But if the supernova is too wild, it can blast that same gas right out of the galaxy. With no gas left in the area, there's little to no chance a new star could form. Now, what does the future hold? Some scientists can't help but wonder what might happen if no new stars pop up. The universe might be simply filled with black holes and fading stars. Solar systems would become inhospitable as their stars lose power, and those ravenous black holes might munch on whatever material is left. As gloomy as it seems, you do have to admit it's a mind-boggling concept. Luckily, we don't have to worry about it happening anytime soon. The universe is a whopping 13.7 billion years old, but the dark era isn't expected to kick in until somewhere way further in the future. But hey, this is just one possible outcome of the decline in star formation. Who knows what other wacky possibilities the universe holds? In the heart of the galaxy, there lies a mysterious object, the likes of which no astronomer has ever seen. It streaks across the sky like a shooting star on caffeine. So, what is this mysterious blob? And how is it related to the black hole in the center of our galaxy? Let's find out. This thing is called X7. It's the mysterious blob that's been hanging around our galaxy's supermassive black hole for decades. Some even say it's been lurking around there for, like, hundreds of years. We know a few things about X7. For example, it weighs around 50 times as much as Earth. It may sound like a lot if you're an Earthling, but in space, that's like a tiny drop in the ocean. X7 is also moving pretty fast, at speeds of up to 700 miles per second. That's faster than you trying to catch the last slice of pizza before your roommate gets to it. But what in the world is this thing? A magic star we've never seen before? An extraterrestrial spaceship? Well, there are some theories connected to the blob's future tragic fate. Unfortunately, X7's days are numbered. Right now, it's on a 170-year-long elliptical orbit around the supermassive black hole at the center of the Milky Way. But it's not going to make it that far. Each year, it's spiraling closer and closer to the black hole. In just a few years, it will become spaghettified. Yes, that's a real scientific term. And finally get sucked in, never to be seen again. There are supermassive black holes in the centers of all galaxies, including our very own Milky Way. These black holes are so massive that they warp space-time, causing nearby stars to orbit around them at incredible speeds. They serve as cosmic vacuum cleaners that suck in anything and everything that comes close enough. The black hole in our galaxy is called the Sagittarius A star. Sounds like the name of a fancy Hollywood celebrity, doesn't it? But this celestial object is far more impressive than any mere mortal. It's about 4 million times more massive than our sun, which means it could probably eat our entire solar system for breakfast. But don't worry, these black holes may seem really scary, but in reality, they're too small to compete with an entire galaxy. They'll just suck in a couple of the nearest stars, and that's all. Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light-years away. From Earth, we can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole, M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, it would be Iron Man, with his repulsor beams on full blast. Now technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole, beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall toward the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole. And that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds, but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G objects stretch out at the closest point to the central black hole, but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one. And while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater, so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers! That's why scientists believe that X7 isn't a G object itself. but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows? Maybe we'll discover another mystery blob, and this time it's going to be a spaceship. Now that would be awesome. We've discovered Kepler 22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler 22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler 22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler 22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler 22, the star of Kepler 22b, is a yellow dwarf. It's very, very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler 22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, the mass of Kepler 22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler 22b is that it's about 15% closer to its star than we are to the Sun. If Kepler 22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler 22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler 22b will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler-22b can rotate around its star on its side, like, for example, Uranus. What? Didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler-22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler-22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler-22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home, while not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler-22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish, until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler-22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category. But this hasn't been proven yet. But even if, fortunately for us, Kepler-22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex? Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler-22b. That would be awkward if it turns out to be a gas planet, or something like that.